Okay, we're going to look at multi-step trig equations today. Some of these problems require a calculator. Okay, so this one says, find the values of x given that x is between 0 and 2 pi. We want to give exact answers when possible, otherwise round to the nearest thousand. So we have 2 sine x minus 1 equals to 0. So to start, I'm going to isolate this sine x by adding over 1, then dividing by 2. So we have sine x equals 1/2. Okay, so I always want to try triangles first. So opposite over hypotenuse, this does match a special right triangle. This is a positive ratio, which is in the top 2 quadrants. So we'll draw our 2 triangles. I'm going to label one of these opposite hypotenuse. My missing side length is √3. So we're answering in radians. So this reference angle is pi over 6. And then in the second quadrant, this is 5 pi over 6. So our 2 solutions are pi over 6 and 5 pi over 6. Okay, for this one, we're going to start and subtract over by 1. Secant 2x equals -1. Okay, with multiple angles, we are trying triangles first. So hypotenuse over adjacent, that doesn't match. So then I go on to quadrantals. The hypotenuse for quadrantals needs to equal +1, so I'm going to push that into the denominator. So where does x equal to -1? That's at pi. So we say 2x equals pi. This is one rotation. To get a second rotation, I add 2 pi. Well, 2 pi plus pi is 3 pi. I add a second rotation because that's a 2. And then I multiply through by 1/2. So I get pi over 2 and 3 pi over 4. I'm sorry, I thought this was a 2 here. That's rotation number 2. So when I multiply this by 1/2, it's 3 pi over 2. Okay, again, isolate sine x. I subtract over by 2. 3 sine x equals to 2, dividing by 3, where sine x equals 2 over 3. Okay, when we try triangles, that does not match, and it's special right triangles, and it's not going to be quadrantals. So we have to use our calculator here. The calculator should be a last resort. So this is a positive sine ratio, which is in the top 2 quadrants, labeling like this. Okay, when I type this in the calculator, I need to make sure I'm in radian mode. Oops. Okay, so my mode, I'm in radian mode. I'm going to do sine inverse of 2 over 3. So when I had to hit second sine to get that sine inverse of 2 divided by 3. Okay, so that's this angle in the first quadrant, 0.730. Okay, so that's theta. To get the angle in the second quadrant, remember it's pi minus theta. We have this adjustment chart where when we do the inverse of the positive ratio, we get the angle in the first quadrant, and then pi minus theta is the angle in the second quadrant. Pi plus theta is the third quadrant, and 2 pi minus theta is the fourth quadrant. So to get the angle in the second quadrant, I have to do pi minus, and I go up and grab that angle. And then, so 2.412 is this angle in the second quadrant. Did I write that right? Yep. Okay. Okay, 4 cotangent x equals -5. So I'm going to divide over by 4. This is not going to be special right triangles, not going to be quadrantals, so then we can go to the calculator. Cotangent is equal to a negative ratio. This happens in the second and the fourth quadrant. Cotangent is adjacent over opposite, so I'm going to label it like so. 2 things. When we go to do the inverse with the calculator, we have to change this to tangent. So I'm going to say tan x equals 4 over -5. I did the reciprocal of this. Okay, I just flipped it. And then when we type it in the calculator, we have to type in the positive angle, and that will give us the angle in the first quadrant, which isn't one of our solutions, but we need to use it to find the 2 solutions, okay? So in my calculator, I'm going to type in tan inverse of +4/5. This gives me the reference angle. That is not one of our answers. To get quadrant 2, we do the pi minus theta. So I do pi minus, go up and grab that angle. There's one of our solutions. So 2.467 for this solution right here. And then I do 2 pi minus that angle right there. 5.608. Oops, already have too many and signs. There are 2 solutions. Okay, for this one, I'm going to start by adding over 1. With this squared, I need to square root both sides. When you take the square root, you have to put plus or minus. So square root of 1 is 1. I put plus or minus. This is not going to be triangles. I would try triangles. Doesn't match. So then I go to y over h. So we're looking at where does y equal to positive and -1. This happens at these 2 angles. So I say 2x equals, this is pi over 2 and 3 pi over 2. There's 1 rotation. We need to do a second rotation because it's a 2x. So I'm adding 2 pi. Well, these have denominators of 2. So I'm going to think about this as 4 pi over 2. I just got a common denominator. So pi over 2 plus 4 pi over 2 is 5 pi over 2. 3 pi over 2 plus 4 pi over 2 is 7 pi over 2. Divide by 2 or multiply through by half. We get pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And that's it.